All right. Ozarka again here. We have a video, a section 1.6, and it says more equations. And then there is a ton of stuff after those colons there. Just know this video is pretty involved. Just ahead of time, just to kind of give you a warning. It involves a lot of stuff. So you're going to want to take good notes, pause, rewind, that sort of thing as you're watching this, just because it's going to help you understand this many concepts. And it is a lot. So here we go. All right. So the section objectives right there, determine the values of the variable that are restricted in the rational expression. We're going to do some example problems involving this. Basically, you cannot divide by zero, so we're going to look for certain values where if you did, have a value of a variable, it would cause a division by zero. The second one right there says solve rational equations that reduce to linear or quadratic. So we're going to introduce the idea of what a rational equation is. In this case, for this class, they're always going to reduce to linear or quadratic. We're not going to go above that just because it's kind of unnecessary. It's kind of just more than we actually need for this class. Then we're going to solve equations using odd roots. We're going to solve radical equations, which are different than rational equations. We're going to solve equations involving rational exponents, which are different than rational equations as well, but it's the same kind of idea of what a rational is. And then the sixth one right there is solve equations that are quadratic in form. All right, so the first thing is rational equations. We're going to go over what a rational equation is and basically how to solve it. All right, first thing here is a rational expression is an algebraic expression in which the whole number powers of the variable may appear in the numerator or denominator of a fraction. For example, so it's got these three examples right here of rational expressions. An easy way of thinking about what a rational expression is, anytime you have a polynomial divided by another polynomial, that's essentially what a rational expression is. Okay. Whenever you have like a variable or any of the terms, basically the powers for those terms are going to be whole numbers or zero. It cannot be negative. So if you notice these right here, the values at the top and the bottom, like this has a power of 1, this is a power of 1, this is a power of 0, that 5, it's 5x to the 0th power. This one's squared, this one's a 1, this one's squared, this is a 1. Now, the last one there, it doesn't look like it's a polynomial over a polynomial, but essentially you could be dividing by 1 here. So it technically is a polynomial divided by another polynomial. So a rational expression, you can kind of think of it as like a fraction of polynomials. Okay, and in this case, the polynomials are all going to be like linear or quadratic. So if you think about a linear over another linear, or a quadratic over another quadratic, or a linear over a quadratic, quadratic over a linear, that sort of thing, that's the rational expressions that we're going to be dealing with in this course. For now, we'll both, and it just says it again right here, for now, we'll be interested in rational expressions that involve first and second powers of the variables. Okay, or 0th power as well. Okay, if it's a constant like, a 1 or something like that, it's really x to the 0 power. It's just invisible because anything to the 0 power is 1. Okay, now because we are dividing, it's a polynomial divided by a polynomial, that could mean that every now and then there could be a division by 0. Okay, and you have to understand that dividing by 0 is impossible. In fact, it doesn't really make any sense. It's kind of like it's like a paradox. Okay, you can't divide by 0. How can you can divide something in 2, you can divide something in 3, but how do you divide it into nothing? Okay, it's impossible to do. So because of that, the values that cause a division by 0 are just not defined. These values that cause a division by 0 are called restricted values. You cannot use these values because if you did, you would be dividing by 0. Okay, the other equations that we've solved, we didn't have to worry about dividing by 0 because they weren't rational. Well, I guess they were rational expressions, but they didn't actually have anything in the denominator that would cause a division by 0. Okay, there's going to be examples that we're going to go over that actually do this. Here's this first example right here. It says the value of x equals 2 is restricted because if you plug 2 in the bottom, so if you did 2 times 2, that's 4, minus 4, that's 0, you'd be dividing by 0. So that's why x equals 2 is restricted, because you'd be divided by 0. Again, that's impossible in math. Let's do some other example problems that kind of jump off of that other problem that we just did. So it says right here, what value of r is restricted in the following expression here? So what we're going to do basically is just take that denominator, so 3r minus 15. So look at the denominators on the bottom, this thing right here. And we're going to set it equal to 0 and solve. That's going to actually help you find the restricted value. We're going to add 15 on both sides. We're going to divide both sides by 3, and then r is equal to 5. So the restricted value in this case would be r is equal to 5. You cannot have r equal to 5 in that expression, otherwise you'd be dividing by 0, which again is restricted. We're going to do the same thing with number 2. It says what value of x is restricted from this expression? So that whole thing right there, again, what we're going to do is just take that denominator and set it equal to 0. Because you cannot divide by 0. Since you cannot divide by 0, that would help you find that restricted value. So set it equal to 0. Now this one actually factors nicely. It is a quadratic, so a lot of the times you'll notice that these actually do factor pretty nicely. So this is going to be x minus 2 quantity squared equals 0. Now if you wanted to, we talked about this in the last video, you can use quadratic formula to solve these if you want. Completely okay to do that. We're going to square root both sides. You get x minus 6 is equal to 0. Add 6 to both sides. X is equal to 6. And x is equal to 6 is the restricted value. X cannot actually equal 6 in this expression because, again, you'd be dividing by 0. Okay, so that's the restricted value. So next one, it says, what value of t is restricted from the expression? Okay, so same kind of thing that we had before. We have a quadratic in the denominator this time. We're just going to set it equal to 0. Now this one is not a perfect square, so we could have two answers on this. In fact, we are going to have two answers on this. This one factors, again, if you wanted to, you could use quadratic formula. You would get the same answer. It's going to be t plus 6 and t plus 9 for how that factors. And again, if you forgot how to factor, you're going to want to watch that last video where we went over all that stuff, because by now you should technically know that in this class. The way this class works is everything is going to build off the previous concept, so you have to understand the stuff from before. You can't just skip that stuff and think that you're going to be able to understand the stuff further on in this class. It's just not going to happen. It's one of the big reasons why math is usually not people's favorite subjects, is because everything builds. So if you miss one thing, then for future things are also going to be missed. So you have to understand all this stuff pretty much all the time to really get a firm grasp of it. But anyway, I set each of these factors equal to 0 and solved, and you should get -6 and -9 as the answers for that one. Onward we go. Solving rational equations that reduce to linear or quadratic. So the ones we just did, it seemed like we were solving, and we were solving for restricted values. But now we're actually going to be solving equations. So if you notice, the ones we just did were all expressions. There was no equal sign in there. Now we're going to be solving for x, which is like, you know, the traditional thing that we do is solving. We solved linear, we solved quadratic. Now we're going to be solving rational equations, but you'll notice there's an equal sign this time. So we are going to try to solve for x for these values, for these equations. So it says right here, solving rational equations that reduce to linear or quadratic. We will study lots of rational expressions and rational equations throughout the semester. Right now, we are only interested in rational equations that can be reduced to linear equations. We will look at two special cases right now. Basically, rational equations that are proportions and can be solved by cross-multiplying. We're not really going to do cross-multiplying so much because it kind of confuses people sometimes. So we're actually going to show you a little shortcut, better way of doing it rather than cross-multiplying. And then we're also going to look at rational equations in which fractions can be cleared by multiplication. That's primarily the way we're going to do it, is that second one. Important note, make sure you understand this. A solution of a rational equation can never be a restricted value. So we just went over restricted values. It causes a division by 0. You have to make sure that your answer is not a restricted value, because if it's restricted, it can't be the answer. All right, let's look at some examples where we kind of do this sort of thing so it kind of makes more sense. So number 4, it says solve for x. First thing that I always tell students to do whenever you see a fraction is immediately get rid of it, okay? And people tend to not like fractions, so what I would do is just multiply by whatever the denominators are. So this one, it says -6 divided by x. I'm gonna multiply both sides by x. And by multiplying by those denominators, it's going to cancel the denominator, and now you have one less fraction. -15x over x minus 3. So basically the x will just went up here, so it's with the -15x. That's what it is right here. So we have something like this. Now we are not out of the woods yet because we still have another fraction. So what we need to do is now multiply both sides by that denominator. So I multiplied by the x before, now I'm going to multiply by x minus 3. Okay, and this is going to be times, so I'm going to put parentheses there. Okay, the x minus 3's are going to cancel here, and you're going to end up with -15x is equal to, and then I'm going to distribute on that left side, -6x plus 18. All right, now from here, it's just a linear equation, which we solved week 1, okay? But if you notice, you know, this should be pretty easy, but if you notice the very beginning of the equation is super complicated. There's these fractions all over the place. That's why I want you to get rid of those fractions. As soon as you do that, you can get into equations that you should be more comfortable with. In this case, this green equation should be pretty comfortable. I'm going to switch the signs on all the things. You're allowed to do that as long as you do it for both sides, just to make my life a little bit easier. I'm going to subtract 6x on both sides, and you end up with 9x on that side. Divide both sides by 9, and you get x is equal to -2. Now, before we say, oh, that's the answer, it's -2, you're always going to want to check in the original equation, does -2 cause a division by 0? So if I plugged it into the original equation, is there a division by 0 anywhere because of that x equals -2? So if I put -2 in here, is it dividing by 0? No, so we're good to go. If I put -2 into this, -2 minus 3 is not 0. It works when I plug it into both of those x's on both sides of that equation there. So this actually does work for the answer. We are going to be going over ones where it will not be the answer, but this is the first one. It just so happened to not yield a restricted value. So the answer is x equals -2, but again, notice that I plugged it into that original equation where the x's are just to make sure that it doesn't cause a division by 0. Right, let's move on to number 5. Okay, good thing to do with these problems, if you can, is factor them. So right away I can see this actually factors here. I can factor out a 3. So you end up with something like this. Now it makes it a lot easier because sometimes it will cause like you to be able to cancel out certain values. So I always recommend factoring first if you can. We did not need to factor a number 4. You notice there's nothing to really factor, so we didn't have to worry about that. But this one you can, so you should. Same rule as before, I'm going to multiply by the denominators. I'm going to multiply both sides by v minus 5. It does not matter which order you multiply the denominators by. So I'm just going to do the one on the left first. This is going to cancel here, so if you notice one less fraction, but it's also going to cancel here, which is kind of nice. V minus 5 over v minus 5 is 1 over 1, and you're going to end up with 2 over 3 in this case. Now we hit a dead end because 1 is not equal to 2/3. So when that happens, the answer is going to be no solution. So it's similar to the stuff we went over in previous week's lessons as well. If you ever get a false equation, like 1 is not equal to 2/3, that's false. So the answer would be no solution for that one. All right, here we go. We got another solving rational equations problem to work on. So just like before, first thing I'm going to do is multiply both sides by the denominators. This time we have the w minus 4 both sides, and then we also have this 5 here to get rid of. Let's just multiply both sides by w minus 4 first. So I'm going to multiply this by w minus 4, and then I'm going to multiply this entire side by w minus 4. You cannot pick and choose which terms you multiply by. If you multiply one side by w minus 4, you have to multiply the entire other side by w minus 4. You can't pick and choose again. You have to multiply the whole side. That cancels and you end up with w. This whole thing distributes over here, which is going to cancel out that w minus 4, so you have 5. And then we're going to distribute it here as well, and you're going to have 4/5 times w minus 4. Now, if you wanted to, you can just solve this out, distribute that negative 4/5 into the w minus 4. But what you can do is just multiply everything by 5 again. So I can multiply that w by 5. I can multiply the 4 by 5. 4/5 times 5 is just 4. And we have the w minus 4 again. From here, I can distribute that negative 4 to both of these terms here. And you end up with 5w is equal to 20 minus 4w plus 16. Okay, a nice, easy equation to work with. After you reconfigured number 6, it makes it a lot easier once you look at this linear equation to solve. All right, let's work through it here. We're going to add 4w to both sides, so we get 9w. The 20 plus 16 is going to be 36. Divide both sides by 9, and you end up with w equals 4. Again, you're going to want to, every time you get an answer, check. Is w minus 4, will that yield a divided by 0 in the original problem? And if you actually look, it would, because if I plug in 4 here, it's 4 minus 4 is 0, we're divided by 0. Also here, where it's 4 minus 4 divided by 0. Therefore, 4 cannot be a solution. Since there was no other numbers that we picked, the final answer for this one is going to be no solution, or you can just write this symbol right here for null set. There is no answer that you can plug in to number 6, and the equation will be true from it. It is impossible. All right, let's go to the next one here. I'm going to multiply both sides by 4u. Again, the whole side. Multiply this by 4u as well. Okay, from here we're going to distribute, and you have u minus 1. Distribute over here as well, and you're going to have 4u over 6 is equal to, well, these u's are going to cancel, and you just have a 4 here. Okay, now if you wanted to, you can just solve this out completely. I don't really like the fractions, so I'm going to multiply everything by 6 plus 4u. Multiply this by 6 over here, and you get 24. Okay, from here, I'm going to combine like terms. 10u, add 6 to both sides, you get 30. Divide both sides by 10, you get u is equal to 3. As soon as you're done with finding that answer, make sure you plug it into the original. Is it going to cause a division by 0 here? Nope. It's going to cause a division by 12. This is going to cause a division by 0 here? Nope. It's going to cause a division by 3. Therefore, u equals 3 is the answer for this one. And let's move on to the next one. This one says solve for x. First thing we're going to do is actually factor again, because you can. So this is going to be 4 times x minus 4, which is nice because you notice some x minus 4 here too. So it's going to help simplify things a little bit. First thing we're going to do is multiply both sides by x minus 4. Okay, so this whole thing right here is going to be multiplied by x minus 4. And multiply this by x minus 4 as well. And this is going to cancel out a bunch of stuff here. When I distribute it here, basically this is going to cancel, and then I distribute it to the 1, it'll just be x minus 4. So you're going to have negative 5 over 4, this 4 is still here, plus x minus 4 is equal to, well, this is going to cancel with this, so you're just equal to negative 2 here. From here, again, I just don't want to really have to babysit that divided by 4. I don't like fractions, so I'm going to multiply everything by 4 just to make things a little bit easier. If you don't like doing this step, then don't. It's completely up to you. I'm going to, there's only a 4x there, so I'm going to keep that there. I'm going to add 16 and add 50 to both sides, and you're going to get 21 plus negative 8, which is going to be 13. Divide both sides by 4, and you're going to get x is equal to 13 over 4. Plug it into the original. You'll notice there's no division by 0 here, no division by 0 here, so that is your final answer. Okay, we got another one here. And this time it's going to be really important to factor because we have that quadratic there. It's just going to make our life a lot easier if we factor because things will cancel out. And I'm just going to tell you right now, a lot of times the factors for like something like this is going to be basically this and this. It happens a lot. Math teachers do that a lot. The math textbooks do that a lot. So just be aware, a lot of times it does just factor to those. In this case, it actually does as well. Not always, but a lot of times it does. So definitely take advantage of that. Just check really quick. Do those two things match? They do. Awesome. Now we're going to multiply both sides by all the denominators. So I'm going to multiply both sides by w minus 4. This by w minus 4 as well. Let's see here. Distributed here, it's just going to be a 1 because that'll cancel. Distributed over here, and you're going to have 3w minus 4 over w plus 2 is equal to, this cancels with this, so now you just have 10 divided by w plus 2. Sweet, one fraction down, got one more to go. We're just going to multiply both sides by w plus 2. Again. Okay, distribute the w plus 2 to the 1, you're going to get w plus 2. Distribute it to this one, it's going to cancel, so you're left with 3w minus 12. I'm just going to distribute that. This cancels with this, and you have 10. So now that blue equation right there is awesome because it's linear, easy to solve. Again, similar to the stuff we went over in previous weeks. Combine like terms, add 12 to both sides, minus 2 from both sides. So you're going to have 20 over here. Divide both sides by 4, and w is equal to 5. Check the original equation. Is there anywhere where you can plug in a 5 and you'd be divided by 0? And the answer would be no. So the answer for this one is going to be w equals 5. Okay, by now you should probably be getting the hang of these types of problems. So if you want, you can pause it here, try to work this problem out yourself, see if you get the right answer. And again, I just recommend that for all the videos. You see a problem, do it, and then watch the video. And again, it's okay to make mistakes. It's not like this is graded or anything like that, but you learn more from the mistakes. So mistakes are actually a good thing in this case because you're learning more from them. So don't be afraid to make the mistakes. It's one thing to follow along with me and it makes all sense because I'm explaining it and you're smart enough to understand it, but to be able to do it yourself is the key to these problems. So make sure you do them yourselves. First thing we're going to do is multiply both sides by v because the denominator is a v, and you're going to end up with the following. Okay, so anything that didn't have a v in the denominator is going to have a times v with it, so that v becomes v squared, the 8 becomes 8v. Anything that where you're dividing by v, when you multiply, it's going to cancel, so that 2 over v becomes 2. The 13 over v becomes 13. So now we have a quadratic equation. It's quadratic because the highest power is that squared. This case, I'm going to actually try factoring first because a lot of these do factor nicely. But again, if you want to use quadratic formula, if you want to use completing the square, if you want to use any of those other techniques, please just feel free to do those. I'm not going to really care on problems like this. It doesn't say to do it one specific way, so you can do it however you want. I'm going to subtract 8v on both sides. I'm going to add 13 on both sides. and you end up having this equal to 0. And again, from here you can use quadratic formula if you wanted, or you can factor it. This one factors nicely, so again, I'm just going to factor it. It's going to be v minus 3 times v minus 5. So possible answers will be 3 and 5 based on that. But you need to check the original equation. Do either of these cause a division by 0 in the original equation? In this case, they don't, because you're just divided by v. V would have to be equal to 0 for it to be a restricted value, but these are neither of these are 0, so v equals 3 and 5. Let's do another one. Pretty similar. We have that quadratic denominator on the right. It's just factored already, so that's kind of nice. We don't have to worry about factoring that ourselves. I'm going to multiply both sides by x minus 2, just because it's the one on the left, and it's going to be 4 times x minus 2. The 3 over x minus 2 is going to cancel the x minus 2 on the bottom, because we're going to divide both, or we're multiplying both sides by x minus 2, so it's just going to be 3. And the x minus 2 on the right is going to cancel as well, so you're just going to have 3 over x minus 1. Okay, we still have a fraction, so we're going to multiply both sides by x minus 1. So it's going to be 4 times x minus 1 times x minus 2. I multiplied that by x minus 1. I'm going to multiply the 3 by x minus 1. And then when I multiply the right side by x minus 1, it's just going to cancel out the denominator, so you have 3. From here, I'm going to distribute it out. So you'll have x squared minus 3x plus 2 plus 3x minus 3 equals 3. Okay. And again, I'm going to try to get that quadratic. It's a quadratic equation because the highest power is 2. So I'm just going to try to get it equal to 0 here. Just keep working down this math, which is a lot. That's okay. Plus 3x minus 3. And then I'm going to subtract 3 on both sides so that the right side is equal to 0. Okay, combine like terms here. The 4x squared is good to go. The negative 12x and the 3x are going to combine to be negative 9x. And then 8 minus 3 is 5 minus another 3 is 2. So you end up with something like this. All right, so this one, it factors, I believe, but I'm actually going to use quadratic formula just to kind of mix this up. Also, anytime there's an a that's not 1, I tend to just use quadratic formula just because it's a little bit easier in my opinion. So we're going to do negative b, which is negative 9, plus or minus the square root of b squared minus 4 times a times c. Put that line across there, divided by 2a, which is going to be 8. Okay, let's simplify this up here. We have 4 times 4 times 2 is 32, so I'm just going to put a 32 in there. So it's going to be the square root of 81 minus 32, which is 49. So now it's going to be 9 plus or minus the square root of 49, which is just 7, divided by 8. Okay. So that means it's going to be 16, because it's 9 plus 7 is 16 divided by 8 is 2, and then also 9 minus 7, which is 2 over 8, which simplifies to 1/4. So now we have 2 and 1/4 as possible answers, but again, this is a rational equation. You're going to want to look at the original and see, does 2 work? Does 1/4 work? And you'll see actually that 2 would not work. If you plugged in 2 for x here, it's dividing by 0, and here it's also dividing by 0. Therefore, 2 cannot be one of the answers. So I'm just going to put an x through it. The only possible answer then is going to be x is equal to 1/4. All right, onward we go. We have another rational equation here. We got some fractions. Let's multiply both sides by x minus 5. So it's going to be x minus 4 minus 1 times x minus 5. So again, I'm multiplying this by x minus 5 and this by x minus 5. First one, the x minus 5 is going to cancel, so you're left with x minus 4. The 1, it's just going to be times x minus 5, so that's why it says 1 times x minus 5, is equal to x minus 2 times x minus 5. And we're still dividing by that x minus 3 there because we haven't canceled it yet. All right, next, we're going to multiply everything by x minus 6. So it's going to be x minus 4. We're going to multiply that times x minus 6, minus 1 times x minus 5 times x minus 6. The x minus 6 will cancel on the right side, so you're going to have x minus 2 times x minus 5. No fractions, but a lot of mess here. So we're going to try to simplify this. I'm going to expand this out here. So you're going to get x squared minus 10x plus 24 minus 1 times all of this. So it's going to be x, so I'm going to underline this here. So this part right here, try to color code this as much as I can. X squared minus 11x plus 30 is equal to, okay, this whole thing right here is going to be x squared minus 7x plus 10. Okay, it's looking a little better here. All right, first thing we're going to do is simplify this right here. So that's going to be a plus. This will switch signs. This will switch signs. That's going to switch signs. And then we can just add across here. The x squared and minus x squared is going to cancel. Negative 10 plus 11x is just going to be x. 24 plus negative 30 is negative 6 is equal to x squared minus 7x plus 10. All right, we have a quadratic equation. Let's set it equal to 0 by subtracting both sides by x minus 6. So that's going to cancel. Minus x here is going to go to negative 8x. Add 6 to both sides, and you're going to get a 16 here. All right, this one factors nicely. So it's going to be x minus 4 times x minus 4, so it's x minus 4 squared, essentially. And x equals 4 is a possible answer. But we need to look at the original equation and see, is this going to cause a division by 0? It's not, because there's no x minus 4's in the denominator, and that's what would have to be able to divide by 0. So the answer for this one is going to be x is equal to 4. All right, next we're going to be going over examples involving odd roots. Okay, so the root in this case is going to be an odd number, in this case 3 for this first one, but it's the same kind of thing that we've already been doing in other weeks. It's w to the third, so what we're going to do is cube root both sides. When you cube root, you're looking for a number that when multiplied by itself twice, so let's just say it's 2, multiply it by 2 and then by 2 again, so really in total it's going to be multiplying it 2 times 2 times 2, that's 3 times. What number would get you negative 8? In this case, the answer would be negative 2. Negative 2 times negative 2 times negative 2 is equal to negative 8. Therefore, the answer for this one is going to be negative 2. It does not cause a division by 0. You can check your work as well to just make sure that negative 2 to the third power equals negative 8. It does, so that answer checks out. Let's go to 14. Same kind of thing, r to the third equals 25. We're going to cube root both sides. Okay, that's going to cancel out the third there. So we have r is equal to the cube root of 25, which does not break down to anything. So you can just kind of leave your answer like that, and that's the answer. There's not a number where if you multiply it by itself and then by itself again and you get 25. So therefore you just keep it like that. Where the negative 8 did do that, so hence the difference. This one, first thing we're going to do is isolate the cubic by adding 16 to both sides. So if you notice now that cubic part of the equation is isolated, it's by itself. We're going to cube root both sides now. Notice the symmetry with the colors. That's going to chain, that's going to cancel, and we have y plus 3 is equal to the cube root of 16. Okay. And from here, we're going to subtract 3 on both sides. So you have the cube root of 16 minus 3. Now, there is a perfect cube in the 16, and that would be an 8. So really what you can do, this part right here, you can actually break this down into the cube root of 2 times the cube root of 8, because 2 times 8 is 16. Well, the cube root of 8 is 2. So this becomes a 2 right here. And then it's times that cube root of 2 there as well. So another way of writing this answer would be 2 cube root of 2 minus 3. That would be the fully simplified answer for this one. That's because the cube root of 16 does have a perfect cube in there because it has that 8. Because 2 times 2 times 2 is 8. So that would be the final answer there. And I just realized I made an error, and that is embarrassing. This is not supposed to be a 3 here. That's supposed to be an 8. Which means this is an 8. Doesn't really change that much. This is supposed to be an 8, which means your final answer should also be an 8. That's the final answer. That's a typo. I don't feel like redoing this video right now, so I'm just going to change all those 8s and be unprofessional. Hopefully that's okay with you. All right, let's see here. Radical equations is the next thing we're going over. So if you remember from the very beginning of the video, I said this video is going to entail a lot of different types of equations. So now it's we're making a left turn here, basically going from rational equations to radical equations. Radical, though it sounds like rational, is completely different. Radical equations are equations involving radicals and roots. So you're going to see like square roots, cube roots, that sort of thing. A typical approach for solving certain kinds of radical equations is to isolate the radical and undo it by raising it to each side of the equation to the appropriate power. It is crucial that you check your answers in the original problem. Just like we were doing before, you're going to want to check your answers just to make sure you don't get an answer that doesn't actually work. Super important note here too. It says keep in mind that radicals with even indices can never be negative. So you can't actually be negative if you have an even indices. We're gonna go over some problems that show that, just so you kind of understand it. In fact, we're actually starting with one right now. So right here it says examples with radicals. It says solve for W. Okay, square root isn't even indices. Really, there should be like a 2 here. In fact, sometimes you'll actually see a 2 there in some books and sometimes on the internet. But a lot of times they get rid of it because it's just assumed. If it's not there, it's kind of like if you say like x instead of 1x, the 1 is just inferred to be there. But what you can do here is you'll notice the square root can never be negative. So the answer for this one, just right away, no one noticing it's a square root, would be no solution. But let's just say for fun, so that is the answer for sure. But let's just say for fun, you didn't realize that. So what you can do is just solve the problem like normal, but just make sure you check your work at the end. So what we're gonna do is we're gonna square both sides first. Okay, when you square a square root, it cancels, and you have W is equal to -6 squared, which is 36. So you might go, oh, sweet, 36 is the answer. But let's actually try it out. If you plug it into the original, the square root of 36 is equal to 6. Well, we need it to be -6. So this does not actually work as the answer. There's no other answer that works. So again, you're just going to get no solution anyway. So when in doubt, check your work, and a lot of times it'll actually show whether something works or not, and then you'll know if it's no solution. Or you can just remember the rule, even indices cannot have negative solutions. All right, let's do this one now. First thing we're going to do is add 14 to both sides. Remember, isolate the radical. Square root of u is equal to 14. Okay, from here, square both sides, because when you square a square root, it cancels, and you're going to be left with 14 squared, which is 196. Check your work at the very top. Plug 196 in for this u right here. Square root of 196 is 14. 14 minus 14 is 0, so that does work. 196 is the answer. Okay, we got another one here. First thing we're going to do is isolate the radical by adding 1 on both sides. So that gets rid of that -1 there, and then you have 8 right here. From here, we're going to square both sides. That cancels out the square root. And you have x minus 12 is equal to 64. You add 12 to both sides, and you get 76 is the answer. And you can check it again. You'll notice it does work. 76 is the answer. All right, next thing, 19, same sort of deal. First thing we're going to do is add 1 to both sides. So you're going to get 3 is equal to the square root of 3r minus 12. Okay, then we're going to square both sides. Cancel, cancel, and you're left with 3r minus 12 is equal to 9. Add 12 to both sides, and you're going to get 21 is equal to 3r. Divide both sides by 3, and you get r is equal to 7. Which is the final answer. Again, check your work just to make sure. Okay, this one's going to be a little bit different because now we have a variable here and then the radical on the other side. So it's going to lead us to get a quadratic out of this actually, because when we square both sides, now it's going to be u squared. Square root cancels here, and you have u squared is equal to 5u plus 14. Hopefully a light bulb is going off in your head. Oh, that's a quadratic equation. I am going to factor or use quadratic formula. In this case, I'm just going to subtract everything on that right side and then just factor it, because this one factors pretty nicely. All right, from here we're going to have u minus 7 and u plus 2 once it factors. And again, if you don't want to factor it, use quadratic formula, and you're going to get u is equal to 7 and -2. Now you're going to want to check both of these answers. And the reason for that is if you plugged in -2, it's not going to work. Because if you plug in -2 for this u, it's negative, and then it's equal to a square root. You cannot be negative and equal to a square root. Therefore, -2 is not going to be the answer. And the only answer is u equals 7. 21. Okay, we have an even indices with that 4, and then it's set equal to a negative. So right away, we know that this isn't going to work, so we're just going to write no solution. If you wanted to, though, you could obviously check it yourself and see that it's going to be no solution. But for the sake of time, I'm just going to say no solution and move on to the next problem. 22. Odd indices. We're going to cube both sides to get rid of the cube root. And t is equal to 8. Check your work on that. It does work out. So t is equal to 8 for that one. All right, next we're going to be going over equations with rational exponents. So if you remember before, I said a rational expression is a polynomial over a polynomial. Well, in this case, a rational exponent is basically just going to be a fractional exponent. So you can kind of think of it that way. Here is kind of an example of something that you're going to need to understand on this one. If you have x to the, like a fraction, like n over m, like that, you can rewrite it using the radicals if you really want it. Sometimes it actually helps to do it that way. Another thing that you should understand is like x to the 1/2 equals the square root of x, in the same way as x to the 1/3 is equal to the cube root of x. So you have to understand that first formula in order to turn a radical, when it's that radical symbol, which looks like that little check mark, and basically turn it into a fractional exponent, and vice versa. You need to be able to do both of those for these problems. And then it's the same kind of rules that we went over before. You're just basically doing the opposite to actually solve it out. So let's look at some example problems here. We will start with 23. Okay, this one says w to the 1/4 power equals -5. So if you wanted to, what you can do, I mean, there's two different things you can do. If you wanted to, you can just raise both to the 4th power, both sides of the 4th power. It would cancel out the 1/4, so that's going to cancel out with that, and you're going to have w is equal to -5 to the 4th power, which is 625. Okay. Now plug it into the original. You'll see it doesn't work because you end up with a negative. So this ends up being no solution for this one. But let's just say you didn't actually do it that way. There's another way you can do it. If you did w to the 1/4 is equal to -5, you can see that w to the 1/4 is really just the 4th root of w. Okay. And you can't have an even index with the radicals and get a negative out of it, just like we talked about a second ago. So if you wanted to, from that, you can also just write no solution. Either way, how you want to do it will work. And it's the same principle too. You can raise both to the 4th power, and then you check your work, it won't end up working out. But you can actually turn that w to the 1/4 power into the cube root of, or I'm sorry, I shouldn't say the cube root, the 4th root of w. Okay, let's do a few more of these to kind of like seal this in a little bit more. We have w to the 1/4 power. So again, you can turn that into a radical if you wanted, is equal to 3. Now it's equal to a positive number, so this will actually work out. Raise both to the 4th power, cancel, cancel, and you're left with w is equal to 3 to the 4th, which is 81. That is the final answer. The next one, solve for u. We have a lot going on here. You're going to want to isolate that rational exponent. So we're going to subtract 3 on both sides. So it's going to be 6u plus 4 to the 1/3 power. And again, you can turn that into the cube root if you want, is equal to 4. Or if you want, you can just raise both to the 3rd power because it's that denominator there, and that will cancel it out as well. So if you can turn it to a cube root, it's the same thing as keeping it to the 1/3 power. You'll get the same answer either way. You're going to get 6u plus 4 is equal to 4 to the 3rd, which is going to be 64. From here, subtract 4 on both sides. 6u equals 60. Divide both sides by 6, and you get u equals 10. If you check your work, that is the final answer. So I'll highlight it. Next, we have solve for x. Same kind of thing. We have 3x plus 1 to the 1/4 power. I'm just going to turn that to the 4th root just to kind of be different than the last problem we did. Subtract 5 on both sides. You get -2 on that right side. Now, you can't have a negative with an even root, or even index, I should say, because we have that fourth index right there, the 4th root. of that. So the answer for this one's actually going to be no solution. But again, if you actually wanted to solve it out, you could, and you'll notice you get the same answer either way. When you check your work, you'll get an answer, but it doesn't actually work, so it's not a solution. Just for the sake of time, I'm just going to keep going on this, and just note that it's an even index and you have a negative value on the other side. All right, let's go over the next one here. It says solve for z. Okay. First thing I'm going to do, so if you notice right here, it says z plus 2 to the 3 over 2 power. What you can do if you really want it is you can just get rid of that fraction, just like we were doing before. Only this time, because it's an exponent, you just have to square it. So when you square it, that and that fraction are going to cancel, and you're going to have z plus 2 to the 3rd power is equal to 9. And you're allowed to do that because a power to a power multiplies. And when you multiply by 2 and you're dividing by 2, that's going to cancel. From here, you can cube root both sides. And you're going to get z plus 2, because the cube and the cube root are going to cancel, is equal to the cube root of 9. We can subtract 2 on both sides, and you're going to get z is equal to negative 2 plus the cube root of 9. You can check your work on that. You will get this answer, and that's that problem. Okay, same kind of thing. First thing is I'm going to raise both to the 5th power. Okay, that's going to cancel out this fraction here, and you're going to get x plus 7 squared is equal to negative 1 to the 5th power is negative 1. And then we hit a roadblock here, because now you're doing the square root of both sides, but you're doing the square root of a negative. Now that does have an imaginary answer, but a lot of times these, you just write no solution because it's the square root of a negative. So this would cancel out here, and you have x plus 7 is equal to plus or minus I. So you square root it, you have to caboot it. So then your final answer is x equals negative 7 plus or minus I. So it's kind of tying in together the stuff from complex numbers in with the solving the rationals. It is also important to note the other ones we did where we said no solution, those did actually have complex solutions. We just didn't want to waste our time going through those because they weren't with like square roots. So just throwing that out there. This right here, examples that are quadratic in form. So quadratic in form means that if you do some substitution, you can actually get the equation to look like it's quadratic. And it saves you a ton of time doing these rather than trying to expand it all out and doing a bunch of other math. So main thing I want you to see here is, I'm going to highlight this to kind of make it make more sense. This right here, squared times negative 10 times that same thing. So the things that I highlighted in red are actually equal. So if I wanted to, if you notice that pattern where this is to the 1st power and it doubles, and you get this over here, what you can do is actually set u equal to y squared minus 11, and then rewrite that entire original equation to be u squared minus 10u plus 25 equals 0. So what's highlighted in red, I turn it into u, and then you can rewrite it to u squared minus 10u plus 25. So now we can actually solve this using quadratic formula, where we couldn't do that the way it was originally written. Whenever you can do this with an equation, that means it is quadratic in form. Whenever you see a quadratic in form equation, you know you have to do u substitution. So solve for u. It's always going to be that thing that's there where if you double the power, it gets to the other thing. So if you notice the twins there and you double the power, then that's going to be your u. We can solve this like we solve any quadratic. This one actually factors nicely. So it's going to be u minus 5 squared is equal to 0. Square root both sides, you have u minus 5 equals 0. So obviously u is equal to 5. But the problem with that is the equation starts with y. So you have to answer it in y. Okay, if it starts in x, you have to answer it in x. If it starts with y, you have to answer it in y. It does not start with u. You cannot answer it u equals 5. You have to know that u is equal to y squared minus 11 is equal to 5. So from here, I can add 11 on both sides. If you notice, I can now solve for y. Y is going to be equal to plus or minus 4. Check your work on that. You will notice that is the answer is plus or minus 4. Okay, onward to the next one, number 30. If you notice, it's the same kind of thing. You have x to the 4th and you have x squared, so that power doubles. It's usually a telltale sign when the power doubles like that from 2 to this 4 here. In that case now, our u is going to be equal to x squared. Because if our u is equal to x squared, we can rewrite this whole thing to u squared minus 37 u plus 36 is equal to 0. And we have another quadratic in form equation that we can solve using quadratic formula, or in this case, I'm just going to factor again. It's going to be u minus 1 times u minus 36 is equal to 0. And your u answers are going to be 1 and 36. But your u is actually equal to x squared. So you have x squared equal to 1 and x squared equal to 36. So you square root both those and you get x is equal to plus or minus 1 and x is equal to plus or minus 6. Check your answers on that to make sure they work, but they do. It's going to be all four of these basically, so plus or minus 1, plus or minus 6. All right, so we have one more problem in this video and then we're all set. So first thing that you notice here is that this power doubles to this power, so it's usually a telltale sign that again it's quadratic in form. But the problem with this is that it doesn't actually, everything's not on one side of the equation where it's equal to 0. So I'm going to subtract everything on that right side on both sides. So you end up with something like this. Now you can see it a little bit easier how it doubles. Our u in this case is going to be w to the 1/3 power. So you can rewrite the entire original equation, well I should say the red equation, 2u squared minus 3u minus 20 is equal to 0. Now I'm going to do quadratic formula on this. I know it factors, but I'm still just going to do quadratic formula on this because I feel like it's a little bit easier than trying to mess with factoring it because there's an a that's not equal to 1 in this case. So we're going to say u is equal to negative b, so 3, plus or minus the square root of b squared, which is 9, minus 4ac, which is 4 times 2 times negative 20. And then all of this is divided by 2a, which is 4. Okay, from here, the negative negative is going to be a positive, and you're going to have the square root of 169, which is just going to be 13. So it's going to be 3 plus or minus 13, because it's the square root of 169, divided by 4. So that's going to lead us to getting answers of 16 over 4 and negative 10 over 4. So the answers are going to be 4 and negative 5 over 2 for your u. But the problem with this is we can't have the answer in terms of u. So what we're going to do is we're going to say the w to the 1/3 power is equal to 4, as well as the w to the 1/3 power is equal to negative 5 halves. We're going to cube both sides, so their w becomes 64, and the negative 5 over 2 is going to become negative 125 over 8, and those are going to be the two answers. All right, so that is a very, very exhaustive video on solving a number of different types of equations. We had rationals in there, we had radicals, we had quadratic in form. If you have any questions about anything in this video, let me know.